if this is good. Is this what you mean by number 10?
Let me get my book out real quick. Hold on. 434. 4x, yeah, that one.
Okay. So for this one, it wants you to find the area of the region enclosed by the lines. And will you get a graphing calculator, or do you have to do this by hand?
You mean on the test?
Yes. Yes. Okay, let's just do it by hand, and we'll see if that's
Okay.
fine. So because they're both solved for 4.
What he did say today was that for some of them, like for the integral ones, like where you have to evaluate it, he would just have us like set it up if it's too difficult to do like by hand.
Yes. Yes.
Okay.
That gets more and more common in this class. All right, so because they're both 4x, you can actually just set them equal to each other. You can set y squared minus 4 equal to y plus 16.
Yeah.
And then you move everything left, so you get y squared minus y minus 20 equals 0.
Okay.
So you factor that and you get y minus 5, y plus 4.
So then it's y equals 5 and negative 4.
Yes, and those are your bounds. We're the kind of the way this one is structured is you want to integrate with respect to y. Do you maybe that isn't clear, but like it's because you really can't solve this one for y.
You mean for x?
Well, you can solve for x, and that's why you're going to integrate with respect to y.
Oh, okay. I see what you mean.
Yeah. So it's the integral from minus 4 to 5, but then we do have to solve both of these for x. So
Okay.
so let me actually just copy this again and kind of reset the problem because I'm limited.
Wait, so do we not need the negative 4 and 5?
No, you definitely need those, but x is y squared minus 4 over 4. X is y plus 16 over 4. And we're integrating from minus 4 to 5. Okay, and the way you figure out which one, because it's right minus left on this.
All right.
So you put it, you choose a value between these two endpoints.
So
like
0. I remember.
0, yeah, and then you plug it in here. So 0 squared minus 4 is minus 4 over 4. That's negative 1. This one is 16 over 4, which is 4. So this one is obviously the right. This is the right, and then this is the left.
So it's y plus 16 over 4 squared, right?
This is not one of those. You're not. It's just finding the area between, not a volume.
Or are those like the washer ones and disk that you do the squared?
Yes, but not here. Minus y squared minus 4 over 4 dy.
Okay.
Is there anything about this that is unclear? Because this is from here, it's not really, it's a chapter 7 problem from here, and like make sure this is okay.
So you just to get it solved for x, you just, what was the thing? Why did we have to do the thing up top, like where we set it equal to each other? Basically, that was just to find the bounds.
We need to find the bounds. Like
okay.
If you were to graph this, you would get all the information we just got, but I'm trying to show you how to do it without graphing.
Gotcha. Okay.
And without even really thinking that hard about where right and left is. You just follow these steps, and
no, it all makes sense then.
Yeah. All right. So now this is kind of non-obvious, but you really want to factor a 1/4 out of both of these integrals, or out of these terms, because then you can put it on the outside and it just becomes easier. Yep. And then it's minus y squared plus 4 dy.
Does the minus apply to the whole, like y squared?
Yeah. Yes. So it's minus y squared plus y plus 20. And then you can find the antiderivative, minus 1/3 y cubed plus 1/2 y squared plus 20y, evaluated from minus 4 to 5.
Yeah.
multiply by 1/4. Do you want us to proceed from here?
Yeah, let's just finish it.
Okay.
So it's 5, everything multiplied by 5 first. And then minus 1/3, negative 1/3 times negative 4. One half times negative 4 squared. So it's 125 minus 64. That's
Yeah. But they're both negative though, so it's gonna be minus 189/3.
Yeah. Over 3, and then 100 minus or plus 80, so that's 180
But you're
minus 8.
yeah, you're subtracting it though, so you gotta be careful.
Well, 100 plus 80 minus 8, right?
Yes.
So 172. And then the 25/2.
Yeah, so from here, common denominator 6, I guess. Isn't great, but this is like at times 2, so is that like 193, 378? This one like feels like it was meant for a calculator.
Probably.
At some point, yeah. And add all those up.
Then that is 1. Okay.
They're both divisible by 3.
Is that times the 1/4 or that?
Yeah.
Okay. Okay.
I don't trust myself that much with these by hand calculations anymore. But so if
Yeah,
this is for a grade, please double
I'll
check.
check it with it. No, I'll check it with the calculator and stuff.
Okay.
Because I still have to do them like myself, like write them all down.
So it looks like 11 is next.
Okay.
11.
The same type of thing, I think.
Yeah. All right. So you're setting, the first thing you're doing is you got to figure out the boundary points. Although there, okay. So that's interesting. The sine x graph, as you know, it goes up and then it goes down. So at like pi over 2, it reaches this point. Let me magnify this, I guess, a little bit. Okay, so let's pretend like this is 1. I'm sorry, this is pi over 2. And when sine is pi over 2, that's when it hits a value of 1 up here. Like it does something like that. We don't actually, but they're saying like no, just cut it at pi over 4. And then there's this line y equals x, which I actually don't know where it hits. But we know that I want to say that it's below here, something like that.
Okay.
But I would like to verify that with a calculator, because it will slightly change the answer here.
Right. So like graph it.
Yeah, and I actually am wrong here. So y equals x actually goes up this way. So it's the region It's this region between the two, which is up here. That's what we're trying to find the area of.
Okay.
So doing it the way I was about to do it, we would have gotten a negative answer and that. So the area between us, you're going from 0 to pi over 4. And this time it's top minus bottom. So it's x minus sine x dx.
Okay.
You know what? Let me just, sorry, I'm looking at the graphic and I think this is, yeah, it is. I've got it. Okay, I was on the wrong zoom. All right, so this is just a fairly straightforward antiderivative. You got x squared over 2 plus cosine x evaluated from 0 to pi over 4.
Okay.
So that's pi over 4 squared over 2 plus cosine pi over 4 minus 0 squared over 2 plus cosine 0.
So then it is pi over 4 squared. So that's pi. Pi squared over 16. Is that what that becomes?
Yeah, over 2 becomes 32. Cosine pi over 4 is square root of 2 over 2.
And 0 plus 1.
Yes.
Okay.
So to me, that's good enough. You could make a common denominator, but you can't combine anything.
Okay. Yeah. All right.
All right, can we move on to the next problem or anything to follow up on that one?
I think we can go next.
So the next one is 21. On to the next page. Find the volume. Oh, this is lovely. So it's a 4-parter, which is, it's really 4 separate problems. All right, find the volume. All right, find the volume of the solid. So we might want to do some things first before getting into the actual problems. Like for example, A says the x-axis, but we maybe want to just figure out where they intersect and do all that first before we get into that. So let's just set x equals y and then substitute that in here. So that produces y squared equals 4y. I know there's a preference to like take a square root and solve for y here, but whenever it's squared, you really want to stay away from doing that.
Okay.
Subtract 4y from both sides, factor out a y. So y is either 0 or 4. So that's helpful because it gives us like some general idea of what this looks like.
So do you put like vertical? Do you put like a asymptotes at 0 and 4 or no?
No, these are just the bounds. They're just the intersection points. So when y is 0, they're both 0. Hopefully you see that.
Gotcha. Okay.
Okay, but this is the graph of y equals x.
Y squared equals 4. That's a parabola, right?
Yeah. So the other intersection point is when y is 4. So when y is 4, that's 4 squared. That's 16 equals 4x. So that means x must be 4. So there's an intersection point at 4, 4.
Okay.
So the graph looks something like this, I think, something like that. Like it's this region right here. Did you get a sense of whether you're going to get, like you're gonna have to graph these, or if you're gonna like have enough information to be able to do it on your own?
I mean, I don't know, because in class we did kind of it both ways, so I can ask him tomorrow. But I'm sure like some of them he'll have us graph. Also, there will be some problems with the calculator and some without, so.
Okay. Well, what's interesting here is that you actually can get away with solving this first one for y. When you solve it for y, you get y equals the square root of 4x, and which reduces to 2 square root of x. So you're going to actually be able to leverage that because of the way the snip is. Like y squared goes all the way around, but you don't need all that in this problem. Like this area is the only thing we're concerned about.
Okay.
Okay, so now that we understand what it is, we have to do each of these. So the x-axis, I mentioned this yesterday. Is there a gap with the x-axis?
No.
So when I say gap, like this, to me, this is a gap here. The region where it's not exactly equal, or it doesn't cover.
But there's, so like a break from the x-axis, basically?
Yeah, a break was a good word. Yeah.
Okay.
Okay,
So yeah.
so that means this is a washer problem.
Okay, well, can you show me again like what it would look like if it was a disk?
Yes. Let me find a space up here. So the disk, it would be like, let's say it's y equals x, and there's no gap.
Okay, got it. Yes.
Okay, so this is a washer problem that we're dealing with here, which means you got to find both r's, the big R and the little r.
So the big R is the y squared equals 4x.
Well, but you gotta solve for y. So it's the 2 square root of x.
So you always have to solve for y.
When you're doing it over the x-axis, yes.
And if you're doing it over the y, you have to solve for x.
Yes.
Okay.
And then little r is just x.
Because it's already solved for y. So then it's the bounds are 0 and wait, I don't know.
So it just so happens that they're the same on the x-axis and the y-axis.
Okay.
So it's from 0 to 4.
And then it's 2 root x squared minus x squared.
Yes, dx.
Dx. So then that's 4 x squared. So then that becomes 4x squared over 2.
Yep.
Which becomes, or cancels, 2x squared, 2x squared minus x cubed over 3, 4, 0. Oh, I forgot the pi. Whoops. Two times 4 squared minus 4 cubed over 3. 2 times 16, 32 minus 64 thirds pi. So then multiply by 3, 32 times 3.
Yeah, it becomes 96 over 3.
Okay. 64 thirds pi. Yeah, okay, great.
All right, so that takes care of part A. Let me go look at part B. So the next one we should do, excuse me, is probably the line y equals 4, which is
Okay.
part D. The reason is that it's somewhat similar to what we just did. It's just a modification here. So try to do like all the horizontal axis problems. So again, our graph is something like this. It's this, and then there's this region, and we're doing it over this line right here, y equals 4. So it's the same question that I asked you in the previous problem, is like, is this a washer problem? And is there a break? Is there a break between this area and the line you're revolving it over?
Yes.
So it's a washer problem.
Okay.
This time though, your little r is this red, that's your little r. And your big R is the blue here.
Okay.
Okay. And with a little bit of like, if we use the same ones as before, like if we, this top curve is, what did we say it was? It was y equals 2 square root of x. That gives us the height, like it gives us, let me use another color here. It gives us this right here, but we want the red. So the red is 4 minus the green.
The red. Oh, this is the one where you have to subtract 4 from it because it's above the x-axis, right?
That is true. Yeah. I mean, that's yeah, that's generally true.
Okay. Wait, how did you get the 2?
That's this curve, this top curve.
Oh, that was given earlier, right?
Yeah.
Oh, that was the y squared equals 4x, right?
Yes.
Okay.
And I mean, I hope you get one where it's already solved for y, or it's not that big a deal, but you generally want to work with them the way they are here. Solve for y if you can.
The bounds are 0.
Yeah, we still need big R though. So big
Oh.
R is that it's that y equals x. But again, that gives you I'm running out of colors, but you can see it gives you this green. And we want the blue. So the blue is 4 minus x.
Okay. So it's the same bounds as before.
Yes, 0 to 4.
So then it's 4 minus x squared minus 4 minus 2 root x with the pi. Yeah. So then you have to do FOIL.
You have to FOIL both of them.
First is 16 minus 4x minus 4x, so minus 8x plus x squared. 4 minus 2 root x. First minus 16 root x.
I do think it's worth combining like terms here as best as you can. So it's like x squared minus 12x
16.
square root of x. And then we're finally ready to integrate.
Yeah, so then it's x cubed over 3 minus 6x squared plus, how do you do the root? Oh, you make that an x to the 1/2, right?
Yeah, yeah.
16x, that's 3 halves over 3 halves. Okay, so x4 cubed 64 over 3. 4 to the 3 halves.
So that's like 2 squared, because 4 is 2 squared to the 3 halves power, and that allows you to multiply the exponents. So that becomes 2 cubed, which is 8.
Because 6 over 2. Okay.
Yes. So plus 8.
right, so then that's 8, and then my common denominator, so, oh geez, 88 times 3. Oh, 24, 3, 6, 24, 20. Is it
So there's-
264? Yeah, okay, great.
So there's a mistake here because we can't get a negative answer.
Oh, we did this last time too.
Yeah, yeah, this is not good. So let me look here. Big R 4 minus X squared 16. This one should have been just 8,
Ah,
and that will affect a lot of things here.
so then it's x squared minus 12x, yeah, plus, yeah.
But is that enough to, so that's 16 over 3. Is that enough to, oh, I didn't, so
We
it's,
didn't do the 16 over 3.
yeah, times 8. So that becomes.
Wait, so it's not 4 to the 3 halves, right? It's 8 to 3 halves.
It is 4. It's still, it was just the coefficient that was wrong.
Oh, wait, yeah, okay, gotcha.
So that's like 128 over 3.
That's still negative though, isn't it?
But it goes with that one. So you
Oh.
get 192 over 3. It is still negative. So there's other mistakes in here. Oh boy. Let me just try this in a calculator and see if it does work from
Okay.
the. Yeah, it does work. Not that that helps, but there is a mistake somewhere in here. The answer is 32 over 3 pi.
Well, that's okay. I know how to do it now.
Yeah, but we probably should continue on, but it's just there's some mistake in here. So what I would do is just start it out somewhere where you feel like it's still good.
Okay.
8, or is that no? Maybe that is 16. Yeah, that is 16. Man, I'm really messing this up. I think that is 16 when you FOIL it. Yeah, it is. So that doubles that number, and that probably is it.
Didn't we have it as 16 before?
Yeah, but I didn't. I'll show you here.
Oh, the times the 3.
We didn't
yeah.
multiply by 32 over 3. And what that does is it doubles this number to 256. This becomes 256 over 3 plus the 64 over 3. So that gets you, that actually will work out nicely. So that's 320 over 3 minus 288 over 3. And there it is. It becomes 32 pi over 3.
Yeah, you found it.
Yeah. All right. So now we're only partway through the problem. We got to go back to, let me go. Yeah. So this time it's over the y-axis. And this time we're going to solve for x in both equations. Let's snip it in. So you'll notice I'm redrawing it every time. You might find that that's very useful here. So it's this shape right here. This is now x equals y instead of y equals x. The other one was y squared equals 4x, but when you solve it for x, it's y squared over 4. Over 4. And then your integral is right minus left.
Mhm.
Your bounds are on the y-axis. They just happen to be the same. So from 0 to 4. Now, is this a...
For this one, if they were different, you would use the y-axis as your bounds?
Yes.
Okay.
Okay, so the big R is the rightmost one. So your big R is y squared minus,
Wait, what? Why would it be, why isn't it the top?
it's right minus left this time. So this is your big R.
Oh, so for x, it's right, it's top minus bottom, and for y,
Yes.
it's right,
Yep.
okay.
Yes. And then the little r is the other one. It's the y squared over 4 squared
Okay.
dy.
Y squared minus y squared. So then y cubed over 3 minus y. You just multiplied 16 times 5.
Yes. Yes, exactly.
Okay.
And then 4 to the 5th
Like always
is,
64 over 3.
I think it's 256. Let me check.
4 to the 5th. 4 times 4
Is 1024
over
over 80.
So, oh god.
The one on the right should be reduced. So the
Did I have to
1020,
do a pi too?
there's a pi. Yes, thanks. So this is really 64 over 5
Oh, that's
because they're both divisible by 16.
so then times 5 on the left, so 64 times 5. I don't know.
So 320 over 15 minus
64 times
192.
3. So then that's 320 minus 192. 10, 1. 128, yeah, over 15 pi.
All right, last
Right.
part here. Make the drawing again. So you got this x equals y. You got this other shape right here, which is the x equals y squared over 4. This time though, you're revolving it around this line.
Okay. Oh, so it's the same. You just do the 4 minus.
Yes. And then you got that's your little r. That's your big R.
Well, wouldn't you get the same thing? Oh, no, because it's right minus left.
Yeah, but in this case, you got to, it changes because it's in this case actually left minus right.
What?
Because of you're going over this line here. But it's big R minus little r. They're just switched in this case. That's why I draw them. Maybe that's
right.
It usually is when it's away from it.
What do you mean when it's away from it?
Or sorry, it's when it's traditional axis. And if it continues moving that way, like let's say it was x equals -1, it would still be right minus left, but because we're overlapping it, the lines over here where the graphs are,
So for the one where it was y equals 4, what was it?
it was bottom minus top. Okay, let's go back and look. So it was the
Oh,
blue.
so like for the ones where you have a line, you just basically flip them always, because that one, the
Yeah,
other one was part A was top minus bottom.
that's right. Yeah, so it does
Okay.
flip.
That makes more sense. That's just how I'm gonna remember it.
Yeah, it's a lot here. So we're going from 0 to 4, and big R is 4 minus y squared over 4 squared, and then little r is 4 minus y squared. dy.
Okay, so 4 minus y squared over 4 squared. 16 minus y. So 6. 4 minus y squared. 4. How do you do y squared times over 4 times y squared over 4? Just becomes 2y squared over 16.
You have to add the exponents because the bases are the same, and then you just multiply the bottoms.
Y. Oh, okay. 1, 4. 16. 4 over 16. All right. So then you do it from, oh no, you got to combine them. So it's 16s cancel, the 8y stays, the 2y squared minus y squared, that becomes minus 3y squared. And then the 4 y squared, y to the 4th over 16.
Yeah.
And then that turns into 4y squared minus 3. Well, how does it become y to the 3rd? Oh, it's y cubed over.
Yes, and then they cancel.
Yeah, okay. Yep, and then 4, 0. So then 4 times 16, that's 64,
Mhm.
minus 64 minus y to the 4th. Oh yeah, 1024.
No.
Again?
Yeah, there's something I miss here.
Oh no.
Let me check it.
Yeah, because the 64s would cancel.
Yeah, this one does work. So I made a mistake. The answer is 64 over 5 pi. $16 those becomes minus 2 because you double it. Oh, this is supposed to be a plus. That will change things.
60 minus. I think the rest is right.
Yeah, well, that does reduce to 64 over 5 because they're both divisible by 16.
Pi.
Yes.
Okay, cool.
Okay, so all that for question 21, 53.
That was a lot.
Yeah, quite a bit there. All right, so 53.
This one has 3 parts too.
Let R be the region of the first quadrant enclosed by the y-axis in the graphs of 2 plus sine x and y equals secant x. So this would be tough to do by hand. So I will graph it. And it says just in the first quadrant.
Yeah. The first
0.
quadrant closed.
All right, so it looks like, let me get rid of that. Oh, they don't intersect. Okay, well, this could prove problematic here. Let me snip in the graph and you'll see what I'm talking about. Okay, so they want the area in the first quadrant. And you see it like this is not a nice number. I'm not sure what that is at the moment. But can you check your book and look and tell me if they give you a numerical answer, like I'm sorry, decimal approximation of part A, or if they actually get a nice.
Chapter 8. They got 53.
Yes.
The two curves intersect at, wait, no. Yeah. X equals 1.22378831.
Yes. Okay. So they actually do that. All right. So they want this area.
Okay.
That's part A. So R is the integral from 0 to 1.224. And then it's top minus bottom. So I guess I didn't show you the top curve is the sine. This is the sine 2 plus sine x. And the bottom one is the secant x. So it's 2 plus sine x minus secant x dx. And the only way to do that is with a calculator. There's no known way to do that.
Okay, so you just plug it in on.
Yes.
Okay. Yeah, well, this is a calculator question, it says.
Part
They
B.
got-
Part B is the solid of revolution of this region.
They got 1.366 for that one. B, I mean A.
Yeah. Okay. Do you want me to check?
No, it's fine.
Okay. So the volume this time is there's a little r and then there's a big R. This is a
Is this
washer
one
problem.
top minus bottom?
It is.
Okay. So the top one is the, what was it, the secant one? Or-
This is the sine. So it's 2 plus sine x squared minus little r, which is
Secant x squared.
secant squared x dx.
And then just plug that in. Right?
Yeah. You get some number out.
Okay.
Let me know when we can move on to part C.
Yeah, we can go.
All right, part C is kind of that starter question here. Like it's saying that these are cross sections of their squares. So you have to find the area of the square, which is base times height.
Oh god.
The base is the difference between the two sections. So it's the 2 plus sine x
Minus secant.
minus secant x, but then you multiply it by itself. So you just square that.
Why do you square it?
Because they're the same.
Oh, I see.
Base equals h, so it's side squared. So you have the integral from 0 to 1.224 again. The area 2 plus sine x minus secant x.
And you can't find that 1.224 unless you graph it, right?
Yeah, that's the only way. This is not a by hand thing.
And then just whatever that gives you.
Yes.
Okay. Great.
Can we stop here, or is there anything else you'd like to cover for today?
Let me think. 8.1. We do like one short one about like maybe like one short disk one, and then
Okay, let's go around the y-axis this time, and let's go y squared equals x from. Well, actually, let me give you another. I'll tell you that y equals 4,
okay.
and we want this in, and then x equals 0 also.
So you have to graph it first.
Y equals 0, 0. Yeah, I'm trying to like limit this problem quickly. So the graph of y equals x squared, it looks.
Well, you solve for. Oh wait, no, you already did solve for x already.
Actually, let's make this 2, so it's graphable. So the graph looks something like this. Okay, but when I restrict it to 0 and 2,
It's just that first, yeah.
yeah, it's just that little bit. And because we're going around the y-axis,
Because you want it solve for x, right? And it
yes.
okay.
So you're integrating from 0 to 2 pi, and then because it's already solved for x, you can go y squared dy. And this is a disk because there's no break.
You don't need to do anything with the y equals 2.
That just gives your kind of your other edge.
Got it. Okay. So then that's y to the 4th, or is it 2y? Yeah.
It's
No.
y to the 4th.
Okay,
So it becomes
y to the 5th over 5. That's 2 and 0. So then that's 2 to the 5th is 3, 2, 4, 5. Yep. Okay, great.
all right. Well, I'll send you the notes here shortly. And if I don't see you into your exam, good luck, and we'll
Thank
see you
you.
next time.
Thanks.
Great night. Bye now.
Bye.